Welcome to lesson 12 in this series on learning Python for beginners. In the last lesson, you looked at how you can combine Boolean expressions in a conditional structure using the Boolean operators. In this lesson, we'll look at two other ways that we can combine multiple tests to create more complex conditional structures. In this lesson, we'll begin by briefly recapping what we've learned about conditional structures. Then we will learn a new conditional structure called Elif and a further conditional structure called the nested if structure. And we'll see how both of these can combine with else to give us a complex series of interlocking logical tests. So let's briefly recap the conditional structure that we've learned. Every structure has a header and a body. The commands in the body are indented. The conditional structure begins with the word if and a logical test, and the indented commands which follow are carried out if the test is true. Optionally, you can have a second header with the word else in it, and the commands which follow that are carried out if the initial test is false. So here's an example which we've looked at already, where we check if a password matches a stored value, in this case Pluto. And we also learned that we can combine multiple tests into a single header using the Boolean operators. In this case, I've used the Boolean operators and not. So now let's look at an alternative way that we can combine multiple tests into a structure, and this is called Elif. Let's imagine we have a conditional structure which begins with the word if and a logical test, followed by commands that will be carried out if that test is true. With Elif, we can add a second test. So if the first test fails, we can add another test, the word Elif, and a new test. The commands that follow will be carried out if the second test is true. And we can continue to extend this structure with as many tests as we like. I often use this structure following menus, so the user will choose one of the menu options and the computer will go down checking each menu option and carrying out the commands that belong with that option. We can also extend the Elif structure with a second test, a third test, as many tests as we like, finishing up with an else command. And the commands that follow the else command will be carried out if all the previous tests are false. So that's very useful. For example, if you had a menu structure, you went through all the options in the menu, carrying out whichever one the user had chosen, and then if they hadn't chosen a valid menu structure, then following else you could have a command saying you didn't give me a valid answer. So let's look at an example. In this example, the user inputs a number and we convert it to an integer. If the number divides exactly by 2, that is, if the remainder when the number is divided by 2 is 0, then we print out the command, print out the message, this number divides exactly by 2. If it divides exactly by 3, we print out that this number divides exactly by 3. And if both of the tests fail, we print out that the number does not divide by 2 or 3. Now notice that in an Elif structure, the computer will go down the series of commands until it finds one that's true, and then it will carry out those the commands in that part of the structure and then leave the whole structure. So in this example, if I entered the number 4, it would print out the number divides exactly by 2. If I entered the number 9, it would print out 9 divides exactly by 3. But if I entered the number 6, it would only say that it divides by 2. It would never get on to check whether it divides by 3. So just to recap, the computer starts at the top, goes through all the Elif commands, trying out each test, and when it finds a test that's true, it carries out the commands and exits from the structure. All the tests in an Elif structure are at the same level of indentation. If you look down the page, they all line up with each other. The computer will look down all the tests until it finds the first one that is true. And if all the tests are false, it goes to the section that's headed by else. An alternative to Elif is what we call a nested if. That's an if inside another if. So let's have a look at that. Supposing I've got a structure where I've got an if followed by a logical test, and then some commands that are carried out if that test is true. Indented inside that structure, I could have a second if structure, and then I get double indentation. And the second lot of commands would only be carried out if test 1 is true and test 2 is true. So it's going through a double indentation to a series of commands that are only carried out if both tests are true. You can see how this is different from Elif. The tests are not at the same level of indentation, and the computer carries them out one after the other. I can add an else as well. So here we've got the same structure. We've got if test 1 and some commands that are carried out if test 1 is true. Then we've got if test 2. That's only carried out if test 1 is true. If test 2 is true, then another series of commands are carried out if both tests are true. Now I can add an else. That else is carried out if test 1 is true, but test 2 is false. I can go even further. I can add an else right at the end, and that else will only be carried out if test 1 is false. So it's quite a complicated structure, and you have to look carefully up the screen and see where the indentations are to see which else goes with which if. So let's look at an example. Supposing I enter a number and convert it to an integer. If the number divides exactly by 2 and the number divides exactly by 3, I write the number divides by 2 and 3. Else, it has passed the first test but not the second, so I say it divides by 2 but not 3. And this else belongs with the starting test, and it says the number does not divide by 2. You can try that out for yourself and see if you can adapt it so that it correctly identifies numbers that don't divide by 2 but do divide by 3. So see if you can make that work. So these kind of structures are a little bit more complicated. There are multiple levels of indentation, but it greatly expands the power of your programs to use multiple tests in various different ways. So to recap, when we use nested if, we put one if structure inside another one, so we have more than one level of indentation. The computer will only get onto the second test if the first test is true. And if you use else commands, be careful to check your indentation to see which test the else command belongs with. So let's try some examples of that. Here are some programs that you can have a try at. Get the user to input a month number and output the name of the month. So if they input 3, it will output March. And you could also have a command at the end if they enter a number that isn't a valid month number. Create a divide program. Input a number, output whether it divides by 2, 3, both or neither. you can use the example that I've shown you in this presentation to get you started on that. And here's a more open-ended one. Get the user to enter a percentage, let's say 50% or 70%, and then output a message saying what proportion that represents. For instance, more than half, less than half, exactly half. And you could then expand that to cover thirds. You could have, oh, it's nearly a half, it's almost a half. So a number of different ways of interpreting percentages. That's a much more open-ended sort of program idea. So just see how you can get on with that, and that will give you a little bit extra to be doing as you get ready for the next lesson. So in the next lesson, we'll be looking at using a different kind of conditional structure where we try a command and it gives us something to do if the command goes wrong. So that's a very useful final conditional structure. So see you in the next lesson.